Hi, I'm Andrew with Nile. Traditional segmentation across wired and wireless networks often leads to policy drift and operational overhead. I'm going to show you a unified model where identity based policies automatically follow users and devices everywhere. User and device segmentation on most networks is still tied to VLANs, subnets, and NAC workflows. As users move between wired and Wi Fi networks, or as devices appear across different sites, maintaining a consistent policy becomes operationally complex. IT teams often rely on VLAN steering, reauthentication workflows, or mutual policy updates to maintain segmentation, which introduces policy drift and troubleshooting overhead. Nile approaches segmentation differently. The Zero Trust fabric enforces policy based on identity and device context, not network location. Access decisions are applied per flow by the fabric, so users and devices retain the correct security posture regardless of how or where they connect. In this demo, I'll show two outcomes. First, identity-based segmentation that follows a user across wired and Wi-Fi networks without relying on VLAN changes. Second, agentless device classification with automated quarantine, where unknown or non-compliant devices are isolated through the policy rather than disruptive network changes. Here's a finance policy group where membership is driven by IDP. Now I'll open John's security details to confirm he's classified into the finance group based on identity. As seen here, he is mapped to the finance policy group. If I click the details for John, you see that he is connected on the wired network and he is authenticated via SSO. Now, the policy matrix, a single view of segmentation intent across user, device, and application groups. For finance, you can see what is allowed and denied. Finance can reach finance apps and the internet, but cannot reach engineering apps. Also take note of the baseline, no impact allowed. Access requires an explicit policy. Now John reconnects over Wi-Fi on a different subnet and gets a new IP address. Even with this new IP, John stays in finance because the policy is identity and device context based, not tied to the VLAN or subnet. As seen here, John is now connected to the employee SSID and he is authenticated via SSO. Now we'll switch to a device example. Here's an IP-based speaker policy group based on agentless fingerprinting. Device validation is enabled. This demo uses HTTPS with an expected corporate credential. A rogue IP speaker is plugged in, and because it fails the HTTPS credential check, it appears in the quarantine policy group, even though the fingerprint for this device matches. With Nile, quarantine is deterministic and policy-based. There's no VLAN change, no subnet move, no IP readdressing, and no reauthentication or COA choreography. It is the same attachment, just tighter policy posture. In the policy matrix, admins can reach quarantine based on the IT admin IDP group and only via approved admin protocols. Unlike VLAN-based quarantines, Nile's quarantine policy group is not a shared pen where bad actors or malware can propagate laterally. With Nile's Zero Trust fabric, devices in quarantine are isolated from each other, eliminating lateral propagation amongst quarantine devices. After remediation, in this case, fixing the corporate credential, the device can be revalidated and moved out of quarantine, again without disruptive network changes. To summarize across both scenarios, Nile applies a consistent identity and device-aware policy model with per-flow verification enforced by the fabric without relying on VLAN or subnet constructs for security intent. In summary, security stays consistent as users move across the network. Threats are contained automatically through agentless classification, and operations are simplified by eliminating legacy segmentation complexity.